Myself, Beril Arun Kumar,
And myself Bhakti Prasad.
and today in this experiment we are going to find the magnitude response and the phase response according to changing the frequencies. Uh, this is our experimental setup is this. For this we need a speaker, oscilloscope, and this signal generator. From this signal generator we are taking the input from this wire to speaker, and the speaker is connected to this piezoelectric substance on the avoid. According to the frequency we are going, the piezoelectric substance is going to vibrate with the same frequency, and it is going to give some output signal through the channel 2 for this oscilloscope, and we are giving the same input signal from which we are giving to the speaker to the same signal is going to the oscilloscope.
In this signal generator, we are generating a sine wave of amplitude 10 volt peak to peak, and we are varying the frequency from 100 Hz to 10 kilohertz in a step of 100 Hz. And when we vary the frequencies, it can be seen that the amplitude response, the phase response of the output wave is changing. If it is not visible manually, we can measure that using this measure button here. We can select channel 1 peak to peak. This is showing the output voltage of channel 1, which is the input one, and for channel 2 we have to change the source to channel 2 and select peak to peak. Now we can see the VPP of channel 2, which is coming from this piezoelectric sensor. So we can see that as we are varying the frequency to 600 Hz, 700 Hz, likewise the peak to peak voltage of channel 2 is changing. It is increasing now. I am increasing the frequency. So we will be taking the readings of the input wave and output wave as we vary the frequency here, and we will be saving that in a pen drive. Yeah. We'll be going to setting and storage. Then we can say choose sine wave and screen, and we will change the format to CSV, and we can choose where we have to store the data, and we can click save to save that wave form. Likewise, we can measure the phase response of both the waves, and we can also measure the phase difference. We have to go to measure, then select others, and phase f minus f. Then it will show the, sorry, we have to change the source also, channel 1 minus channel 2. So this will show the phase difference of both the waveforms. We don't need the phase difference of channel 2 minus channel 2 because it will be always 0. So we can remove that. Okay. Plus we will be plotting the graph of gain versus frequency and phase.
This is the graph of our first experiment, which is the piezoelectric substance. This is the graph between the gain and the frequency. Gain is equals to 20 log V output by V input, and we plotted the graph between the magnitude and magnitude response and the frequency, and the graph looks like this. And we got the uh, resonant frequency at 1900 hertz, and we can find the bandwidth by measuring the difference between the upper and lower frequencies at which the gain drops by 3 dB from the peak gain. From the calculation we got bandwidth is 1200 hertz, and we know that quality factor is the ratio of resonant frequency and the bandwidth, which is equivalent to 1.58 in this case. This is the another graph for the experiment number one, which is in between the phase response and the frequency. As we can see here, as we increase in the frequency, the phase difference is going to be increase in the terms of degrees. And we can see here the phase difference is changing from plus pi to minus pi. And as the frequency is going to increase, the trend as follows.
Response versus frequency. This is our experiment 2. In this experiment, we will be demonstrating the frequency dependent response of photodiode. So, for this experiment, we will need an LED and one photodiode, a 330 ohm resistor, one 10 kilo ohm resistor. For powering the LDR, we have taken an Arduino which is connected to the laptop there. So through Arduino wire. So in the circuit we have taken one input from the signal generator all the way to this breadboard. In this the one wire, one connection is this and another is this one. So we have connected one LED, the positive terminal is this and negative terminal is this, and this is a 330 ohm resistor connected across, and will power the LED. And we have taken the signal from across the 330 ohm resistor all the way to channel 1, and in the oscilloscope it is showing the reading like this yellow sine wave. For the second connection, I have connected the photodiode. This terminal is negative one, and this is positive one. The negative terminal is given a input voltage of 5 volt from the Arduino from here, and another terminal is connected to a 10 kilo ohm resistor, and that 10 kilo ohm resistor is connected to the ground of the Arduino wire, to this orange wire. And the output of the LDR is taken across the 10 kilo ohm resistor all the way to the channel 2, and the graph is shown here. Now
from the signal generator we are taking the frequency readings. Now it is firstly on the 100 hertz. We can see the peak to peak value like 120 millivolt, and we are continuously changing the steps, the frequencies. Now I change it to the 300. Now the peak to peak value is 168, 180. It is changing, like where we can observe the noticeable peak to peak value. We will read that, we will note that frequency values, and we will increasing the step size if we not find the noticeable frequency, noticeable peak to peak value at that frequency. And we take an n number of values up to the 20 kilohertz, 20 megahertz. This is the input graph and this is the output graph, and now we are expected to note the phase difference between these two graphs and the input and the output voltage, and these are available at this in this option measure channel 1, and we are expected to this peak to peak value, so it was came over here. In the same way, going to channel 2, again we have to select the peak to peak. It was available here, and again we are expected to note the phase difference between the channel 1 and channel 2, and here is the phase, and we have to select the phase difference between channel 1 minus channel 2, and we can see over it is here.
this is the graph of magnitude response of the second experiment. The magnitude response of photodiode at varying frequencies. In the y-axis, we have 20 log gain, and in the x-axis, we have frequency in the logarithmic scale. And as we can see, in the lower frequency range, the gain is not changing that much. It is behaving ideally, and in the higher frequency range it is decreasing. We can calculate cutoff frequency by getting the 3 dB level of the gain, and in our case the cutoff frequency is 100 kilohertz. This is the graph between phase response and frequency of a photodiode. As we can see, at lower frequency, the phase difference is very low, and as we are going to higher frequency, the phase difference uh, is decreasing, and at higher frequency, like 10 to the power 6 hertz, the phase difference is increasing.